Good morning. Okay. So Ted took up a lot of my time. Buy me a beer tonight, something. Okay. As I mentioned maybe a little bit earlier, that we do a lot of things associated with geothermal in terms of education, in terms of instrument supply, in terms of equipment supply, system design, system integration, and we're also into a little bit of EPC work, building construction plant, or just building and construction power plants, geothermal power plants for our customers in Taiwan. And I think Herman showed a photo of a project that we are executing right now in Jingwen. Project name is two projects, Hongli, Pai. So those are 1 megawatt each. Okay? But you know, in today's world, data is really important. How do you get good quality data is super, super important. Now, how do you make use of the data? Put some intelligence into the data to make the data work for you is even more interesting. And so what we do is we also do a bit of AI in our company. It's a small company, but we help our customers through remote monitoring. We collect the data. We store the data in a very professional historian. We do visualization of the data, and then we do analysis, and eventually we do some diagnostics. And today our diagnostics is manual. I do the diagnostics because I understand the equipment. I know the domain, I have the domain know-how of a lot of these equipment, so I do the diagnostics. But our next step is to use a bit of artificial intelligence to help us find data that does not look right, or anomaly data. Okay. And then by using supervised and unsupervised, we hope to achieve a certain level of artificial intelligence so that we can advance into predictive analytics, or what's called prognostics. So you determine the equipment health way before the equipment fails. And the key thing there is you must have good data. So data is really, really important. So every product that we sell, we collect the data, we analyze the data, and hopefully we can get to the point where we can do the analytics. So the products that Orcan sells, the product that Lululemon sells, we all have remote access. We all are able to collect the data remotely and analyze, track the data, analyze the data, and provide our customers with advice on what's going on with their equipment. In fact, I just received an email this morning about a project that we have in Taiwan. The H2S scrubber was not behaving. So the data was really been off for the past few days. So we informed the customer this morning that, hey, if that H2S scrubber is not taken care of, then you could damage the engine fairly quickly. So it's really important to have good data and then use good data. So my talk right now will be on a very interesting device. This device is only out on the market for about 2-3 years, and it's made by a fairly famous company called Vaisala. Okay? They're from Finland, around Helsinki, and they specialize in MEMS-based sensors. They're probably one of the largest producers of humidity sensors. So a lot of the semiconductor plants in Taiwan use the Vaisala humidity sensor. Okay? Now, I don't touch that part because someone's overdoing it, but they're having challenges selling this new instrument. This is an instrument that uses MEMS technology coupled with a certain IR to generate information of methane, CO2, and moisture and dew point in the gas. Okay? And I'll show you a little bit why this is important. But it's the only probe that I know in the world that can do these 3 measurements. So method 甲烷、二氧化碳跟水分 in a single probe, online in situ. So non-extractive， 不用采样了，它就直接插到管子里面就可以量了。Okay? So this is a little bit about Vaisala. I didn't know that they were that big, but they're huge. They're a €500 million company back in 2022. Okay, and what's also more surprising is that on the sensors that they use, they fabricate those sensors in their own clean room. So they actually have a clean room, and they spend about 12% of their income, of revenue, on R&D. That is quite high. Okay? And that's why I think that's why they're so big. Workforce population 2,000, 25 offices in 70 countries, 300 different products, and I'm only responsible for 2 in Taiwan. Okay, 2 industrial products. One is that probe, the gas probe. The other one is a probe for measuring gases in transformer oils, so large transformer oil. So in 2022, they spent 62 million euros just on R&D. So quite serious on R&D, very important. That's how you sustain your business. That's how you keep on moving forward and beat the competition. This chart is a little bit busy, but this chart shows the carbon cycle in our industry, in our world. Okay? From the gas source to the gas use, and then hopefully, eventually, gas storage. Okay? So next I'll be making a little bit more clear. So in terms of gas source, obviously when you use geothermal, most likely you will encounter NCG. Well, how do you, if you're concerned about greenhouse gas or global warming, how do you account for the NCG? In some cases, the NCG is not so much, but in other cases, the NCG can be quite high. And so how do you monitor the NCG effectively? Pipeline injection, because in a natural gas pipeline, moisture is really prohibitive. You don't want any moisture in that pipeline, so you have to monitor the RH, or the dew point in that pipeline. Anaerobic digestion, Qi. So this is we really care about CH4 and CO2 because CH4, this ratio of these two is an indicator of the reactor performance. Okay? Livestock, obviously animals, people, we have when we eat, there are things coming out, and the gas that comes out, the fart, is the biogas. So same thing for any animal. Okay? Primarily cows, they make a lot of methane gas. Methanization, so taking other fossil-based or non-fossil-based fuels and converting it into methane. So taking carbon dioxide through certain chemical processes, you can actually produce methane. And then biogas upgrading. This is not very big in Taiwan yet because our biogas industry is small, but in many Northern European countries where they have very big biogas plants, it's a big business. You purify the biogas to 99% purity and you inject it into the natural gas pipeline. So in that case there, you really need to focus on humidity control, H2S scrubbing, CO2 scrubbing. So, so these are the parameters that we look at for the application in terms of gas use. Obviously for engines, I used to sell a lot of engines into the biogas industry. I was with Caterpillar, so I sold a lot of engines into the biogas market in Taiwan, in Thailand, in Malaysia, in Australia, in China, Japan, a lot. So, for an engine, for an internal combustion engine, ICE, whether it's an engine or a turbine, these are key parameters. These are very important parameters, the methane, CO2, and relative humidity. Flare methane slip. If you have extra gas that we get rid of, then you use a flare, a torch, to burn off the methane. But sometimes you have a methane slip in those systems because the flare may not be well designed, so you have methane slip. And of course, the GWP of methane is about 25 times that of carbon dioxide. Not a good thing, so you want to control your methane slip. Gas drying. Okay, for biogas drying, for engine, obviously, we don't like moisture in the engine, so drying that biogas is really important. Greenhouse gases, obviously in greenhouse, you like to have a little bit higher level of CO2, That's what the plant needs for photosynthesis. Cement and calcium carbide production, big business. I'll show you that in a little bit. Steel manufacturing, petrochemicals, and of course the last one is what's a little bit hot today is carbon storage, carbon capture, storage, and usage. So how do you determine the quality of gas that you're injecting? So you have to monitor your CO2 levels in that gas. This is a probe. It looks like that. Okay, I have an actual demo device there, but because it's made by Vaisala, they use very advanced technologies, so it's super stable. Yeah, super stable. The light source, the IR, the infrared light source, does not have to be changed for 10 years. But the only probe on the market that can have such a long lifetime and stability on the light source, which is probably one of the most critical part of any IR device, is the light source. Okay? It's fairly compact. The head is this part here in the white cap. The white cap is actually a Teflon filter because you don't want to dirty the optics inside. So it's a Teflon cap. It's a hydrophobic cap, so no moisture, no condensation can happen inside the sensing region. So there's one emitter and 3 detectors, one IR source, but 3 different detectors for 3 different gases. Okay. It's also explosion-proof rated, so it's fairly highly rated. It's good for the oil and gas industry in most cases. And depending on your application, the accuracy of the CO2 measurement could be done as low as 0.1% accurate. Okay? So if you're looking for methane slip, you will need to use this NGP 262 for lower range and but better accuracy. These are the general specs of the 261 product. Okay? And again, it only measures 3 compounds: methane, CO2, and moisture. And so methane and CO2 is 0 to 100%. And then the moisture level is 0 to 25%. Okay? We had this probe here in the office for about 2 years. Never had to calibrate it. Very, very stable product. We sold some in Taiwan, we sold some into the United Kingdom, okay, for gas engine applications. And let me just go back. And you can see from the photo here, it's what we call a in situ all-in probe. So you don't need to extract the gas. You just install the probe directly into the pipeline. So very simple installation, very, very fast because it's non-extractive. Okay? It's online, instant. So in terms of some of the applications, NCG. Well, I can't show you the customer names, but these 2 NCG results are from my 2 customers in Taiwan. 2 different sites, 2 different wells. As you can in NCG, there's quite a bit of CO2, and a little bit of methane. And unfortunately for these cases, they don't have any H2S. So the NCG is not corrosive, it doesn't smell. So, and similarly for this case here, NCG, the CO2 is 91%. So, but if you're going to play it big in geothermal, how do you account for the NCG release, if you have to release it? I mean, there's ways to also pressurize, keep the fluid pressurized and re-inject the NCG. But if you can't re-inject, then how do you account for the carbon footprint created by the NCG? Okay, so this is an interesting application for NCG. NCG monitoring. Calcium carbonate. This is a very, very important industrial product. It's really a filler that we use for many different applications, from paper making, medicine, pharmaceutical, plastic industries. It's primarily used as a filler. It's a very cheap filler, and the color is very white. It's very consistent, very easy to use. So it's a big business. But in the precipitated calcium carbon reduction, you need one calcium and then one carbon, a CO2 for the reaction. Okay, so and then for the regular carbon, calcium carbon reduction, that's for again one calcium and one CO2. So it's sort of important to monitor how much CO2 you're putting into that reaction. Okay, and if you drive this reaction at about 300 Kelvin, you drive it a forward reaction. But if you go up to a higher temperature, like in a cement production, up to 1200 Kelvin, you drive a backward reaction. Okay, so monitoring the carbon dioxide is quite important for those industries. Those are also about the TCC production. We'll go through it, but it's a live case. They did in Finland. Okay. Biogas production in AD. So here is a comparison of 3 different technologies. The black one is a standard wall mount 4-gas biogas analyzer. The green one is the probe that I'm talking about today. And of course, the orange one is a typical portable 4-gas analyzer, but usually not so reliable because it's a portable device. So you can see that when you compare these devices, the Vaisala probe, the MGP, is a good match with the very expensive wall-mounted 4-gas analyzer. Okay. And we did the same experiment ourselves because you want to sell something, you got to prove to yourself that it's working. So we did the similar experiment ourselves here in Taiwan, and really it tracks a wall-mounted 4-gas analyzer quite well. And we also distribute a wall-mounted 4-gas, a German brand. I won't talk about it here. Emissions abatement. Okay, this is about methane slip and how it impacts your productivity, impacts your carbon footprint, etc. But depending on what your application is, we can have either a fairly high accurate model or a regular accuracy model. But just in conclusion, okay, to be very quick, is in today's world, a lot of our process, a lot of our thinking is data-driven. Okay, so how do you generate good and reliable data, stable data, and cost-effective data? Cost-effective means that you don't have to calibrate it and worry about the data quality all the time. So it means you need a very, very stable, robust, reliable instrument to generate high-quality data for you. And then, of course, you have to use the computer to help you do some analysis, but then you need to apply your domain know-how to identify what the data means to generate useful information to take action. At the end of the job, people have to create the work, and people have to finish the work. But in between, we try to use good instruments, good data acquisition systems, good data management systems, good analytical tools to process the data to generate useful information for either the equipment or for the whole plant. Thank you.